We're going to talk about how to use this in a practical application when we wire it to a blower motor. We're also going to talk about how to wire it in an unpractical application when we take it to the Camtex box. And we're going to take it to the smart board and we're going to show you how to wire this up step by step. Hopefully this gives you confidence to be able to stock this item and be able to get your customers back up and running and with the manufacturer's intention. Stay tuned. Today we're going to talk about the ICM 255 blower board relay. So this is a blower control board. As you can see here, the circuit board, and the black square that's on here is the relay. We have 3 terminals on this relay. We have the common, which is your input voltage, and then we have 2 different output. We have a normally open and a normally closed. I'm going to demonstrate both of these while I toggle 24 volts for the blower control board to toggle the relay for normally open or normally closed. Now, as I said in all our other videos, that the control boards always have to have 24 volts at all times because they are a working load. Getting into it, we have the Camtex box here. We have R and C, which will provide our 24 volts that we're going to need down here for the control board. We have L1 and L2, which is a realistic power supply of 240 volts, just like we have in the field. And as you can see up here, we have T1 and T2, and we have to put that 240 volts up here, breaking it across the relay, one of those legs. And once we do that, we can get our load to come on. I'm going to show you what happens when we just bypass the relay and go from L1 and L2 right to T1 and T2, not breaking anything. We're going to go ahead and connect L2 to T2. There's one leg of power done. We're going to go ahead and connect L1 to T1. And the moment I touch T1, the load will come on. That clicking noise that you heard is a contactor inside the box. So what we're going to do now is we're going to take L1 and we're just going to energize our common terminal on the relay portion of the control board. We're going to come out of that with our normally closed, just to show you that there's always power there no matter what. I'm just going to touch T1. And so as you see here, if we were to leave it there, the load is always energized. If we were to come down and wire it to its traditional terminal, which will be the normally open, that's open now, so there's no power there. So our load, it has L2 present all the way through, but it's lacking L1 because we're breaking L1 across the relay. We're going to go ahead and energize the board with common and R, 24 volts. Okay, it's nicely labeled for you, R, C, and G. So G is not ground. G is actually our blower terminal being wired from the thermostat. We're going to go ahead and take R and run it over to R. And now our control board, as a working load, has 24 volts on it at all times. Now we're going to run a G call. So in parallel, I'm going to take 24 volts again, and I'm just going to go ahead and touch G. And there's about a half a second, maybe a second delay there, and the load came on. Now, here's why this board is important. If I wanted to get more efficiency and save a little bit of money and get more comfort out of my evaporator coil, once I lose the G call, the relay is still closed. Now it's closed for 50 seconds. We're going to demonstrate that off time here in a little bit. This is a very easy board to wire up. Probably one of the most simple boards to wire up. There's no integrated fuses on this board. There's no additional wires that have to come on this board, such as white O's or Y's, Y2s, anything like that. So you couldn't use this board for a variable speed blower motor, but for a PSC motor or even just a standard ICM, you could use this board, because what you're doing is you're just trying to get the board to stay with the relay energized for about 50 seconds. We're going to try that one more time. This time I'm going to put my timer on it. We're going to run the G call up. I'm going to look at the time, and I'm going to go ahead and touch it and get it to come on. I'm going to hit start the moment I release power on G. And you should see a 50-second off delay. And we're going to do this one more time because I think my phone may have been out of the camera view for just a little bit. Another 15 seconds and it should open up and the load should turn off. So your fan motor will be running this entire time. We're also going to take this over to a blower motor. We're going to wire it up to a blower motor also. Now it's about 52 seconds. We're going to try that one more time, and I'll make sure I have the timer center of your screen. Okay, we're going to go ahead and energize the terminal. So G now has been told to run. We're going to release G and hit start. And like I said, it's about a 48 to 50 second off time. And it's very important when you're diagnosing these, if you think if the relay is stuck in the closed position, you want to go ahead and use your timer, because knowing that it's a 50-second off time, you want to make sure that it's not, running for less than that and you're jumping the gun and saying that the board is bad. Because if you're not using a timer, 50 seconds, it's kind of hard to time that out. Just to try and imagine what 50 seconds feels like. Could feel like eternity if you're just waiting on it. All right, so now we have 50 seconds. We're at 52. There we go. And so a little bit of consistency there, not bad. Now we're going to go ahead and take our normally open terminal and pull the wire off of that. We're going to put the wire on the normally closed terminal. As you can see here, the load is energized. I'm going to do the same thing. Okay, I'm going to go ahead and hit reset. And the moment that I go ahead and touch G, you'll see the load drop out like it's supposed to. Now the normally open is getting all the energy. I'm going to go ahead and release G and hit start. And there you go. So as I have a 52-second off delay for the normally open to open, I also have that same delay for my normally closed to energize. And so our normally closed has got that same delay in time. And so that's good if I wanted to use this relay to wire two different loads up to it, where there's 50 seconds on one load and then 50 seconds on the other load, whether it's on or off. So this is giving me an on delay and an off delay in between normally open and normally closed. Any minute now it should energize. Right around 50, 52 seconds. There we go. And so we had about 52 seconds there, and now our normally closed is energized. Now I don't need a G call. This load is running without a G call. And now I can take all these other wires off of this here. And basically, it's normally closed. And so I don't need any low voltage for that relay to be normally closed. However, if I applied voltage between R and C, and I applied voltage to G and then dropped it out, I will have a 50-second delay there. We're going to go ahead and take this over to the smart board in a minute, and I'm going to wire this up. But first, before we do that, we want to go ahead and put this on its practical application. Let's go ahead and wire this up to a blower motor. I'm going to go ahead and take the liberty and take this contact up here. I'm going to wire it to a light bulb. So I'll have the fan motor wired to normally open. I'll have the light bulb wired to normally closed. And then we can see this relay toggle between those two with that delay in a more practical application. Stay tuned. Okay, we're over at the blower motor. We got a PSC motor, run capacitor. We got the ICM 255 blower control board. We have our power supply down here where we have a live 240 volts and a live 24 volts off the transformer. I'm going to go ahead and demonstrate that with the meter. Go ahead and show you that we have live power. I'm going to do it with and without the light. Sometimes it doesn't show up very well. We have 242 volts. Down here we have 27 volts. I'm going to show you with the backlight on now. Again, we have 27 volts. And again, we have 242 volts. I do have an extension cord here. This is to give me a neutral. I'm going to go ahead and stick one of my test leads inside here, and I'm going to go between each leg. You should read 120 volts per leg. That's where we're getting our 240 from. The reason why I have this extension cord here is because I'm going to take this white wire and I'm going to plug it in to give me a neutral. I'm going to go ahead and test that out. And we have a good connection. All right, we're going to go ahead and leave that just sitting here. Now with that, I also have neutral running through my light, so I can also come right here and there's the same 120. So that neutral is a good path. We talk a lot about path of electricity. Very important to understand your path, because when you're troubleshooting, you could get lost. Now on this relay, I have normally open and normally closed terminal. On the far right hand side is normally closed. I'm going to go ahead and plug this light into that one spot. The clip that I have is not a very good clip to fit inside this. I'm going to see if I can't crank that a little bit better and push that wire in there. Give me a second. Looks like I'm making a good connection now. Now this is normally closed, so for me to test that path, what I'm going to do is I'm going to take my meter. In theory says if I normally close between here and common, then I should be able to read neutral over here. How I'm going to do that is I'm going to test to one of my line voltages and see, therefore I have 120 volts sitting here. All right, so I have a good path, so I have a good connection. All right, so now to wire this up, what we're going to do is we're going to go ahead and take one of our lines, and we're going to come up to the one of our legs on our motor, which is the run winding, which has our capacitor, all that wired through to that. I have 3 other speeds that will receive power on one of these other legs. I can plug any one of these into my board, and I will have power, giving me my 220. Now I'm going to go ahead and take the second leg of power, which I haven't utilized yet, and I'm going to go ahead and run it up to common. You'll see the light will come on because it's normally closed. So we forced power across to the load. So right now we are in a normally closed position, so we have a light. We can say maybe this is just standby, there's power. Now the moment that I apply 24 volts to the relay, I will now start having a working low voltage load, even though it's not doing anything just yet, because the board is a load all by itself. So between R and C, it needs to have 24 volts. And so there's no change here because we haven't toggled the G terminal. This blower relay is trying to get a G terminal so it can drop out that normally closed and energize the normally open. Before we do that next step, I'm going to go ahead and take one of these speed taps and I'm going to go ahead and wire it up to my relay very carefully here. Now when I say relay, board and relay, two different things. The relay is on the actual board. Trying to get a good connection here. I'm going to go ahead and disconnect this wire and just run a jumper to it. I think I might get a better connection there. So I'm going to come to my normally open and I'm going to come over here and I'm just going to stick this alligator clip inside of it, and that might be a better connection right now. And make sure that's laying down because these are just floating, so I have to be very careful. That's the thing, if you're ever working in labs, you have to be very careful. Everybody learns a little bit differently, so we start playing with real power so we can understand our application a little bit better. All right, so the only thing we're missing now is a G-call. That G-call is going to come from your thermostat. We're just going to give it 24 volts, and I don't have to keep it on there. However, I'm just going to leave it on there just for a second and then remove it. And you see one load turns off and the motor is running now. And I'm going to show you with my timer the moment we release that G call. The moment we release that G call, there's going to be a 50-second off delay, and then the light will come back on. And go. So this is a off delay, so we just lost the G call, meaning the condenser is probably satisfied from the thermostat, it's cycled off. There's no G call coming from the thermostat, but the only thing that's running is the blower motor. And you're familiar with this already on your ICM motors, where they delay on and they delay on off for a little bit. And we were doing that with PSC motors long before the ICM motor came out. So this is the same technology, same thinking, just a delayed on off. So there you go. The normally closed is now energized. That's why the light's on and the motor shut off. And we're going to go ahead and do that one more time. The G call comes from the thermostat, which we're going to draw that up on the smart board. We're going to go ahead and energize that terminal. The normally closed opens. The normally open will close at this point. Okay. The blower motor is running. I could pick any one of these speeds, whether it's high speed, medium speed, or low speed, and wire it up to it. Your float switch is always wired up to this too, so if you needed everything to shut down, that's pretty much going to happen the moment you lose 24 volts. So let's just say that we weren't getting a G call and say your float switch opened. The moment I lose 24 volts here, the motor shuts off. Now the reason why the light came on is because it's on the normally closed terminal. And so this would represent, hey, we lost power because maybe the fuse is blown, transformer issue, or the float switch was possibly tripped. We're going to go ahead and do that one more time. We'll release other videos where we talk about those safeties and whatnot. Okay, so as you can see, about a half a second delay, it comes on. We're going to go ahead and remove it. And now we have a 50-second off delay. Now, we don't have our timer up here at this point in time to show you this, but this is very easy to not be patient and understand what 50 seconds feels like, close to a minute. A minute can be a long time when you're waiting on it. And so what happens is you can easily misdiagnose this, because when it typically fails, it fails in the closed position, and the fan motor does not shut off. And we can diagnose it with a reader very simply by seeing, you know, between the common and the normally open or normally closed terminal where voltage is present. I like to use the timer because let's just say that this motor was, you know, giving me an issue. I would put my timer out there, and if I knew it was possibly running for maybe 5 or 6 minutes before I got to it, if I could identify that there's no 24 volts between common and G and I'm running, I'm still going to get my timer out, and I might even toggle it a few times and see if I can't get it to, you know, mess up on me. So I would simply put 24 volts on it, remove 24 volts, use my timer on my phone. I would see if I had a 50-second off delay, and if it was still running, sometimes you can just give it a little click. Another way too, if you know if your timer is stuck, you can always remove 24 volts here. It should shut off immediately. If it's still running and you have no 24 volts there, then you have a relay that is stuck in the closed position. So that's another way of quickly troubleshooting this. And pretty much any blower control board, you can remove the 24 volts on the board if you think the relay is sticking. And if you remove 24 volts on it, they should immediately shut off. I'll go ahead and show you again. I'm going to give it a G call. I'm going to take the G call away, and I'm going to remove 24 volts. And immediately, if the relay is good and not sticking, it should shut off. We're going to do that again. I'm just going to remove common just to show you it doesn't matter which order. So how do I know if my relay is good? Without waiting 50 seconds, just remove one of these. That's it. And so I know by either removing any one of those two, I have a very good board. All right, we're going to go ahead and take it to the smart board. Go ahead and stay tuned. Okay, we're at the smart board now. Behind me, we have a timeline on the ICM 255 control board. That's the image we have up here. We have now moved to the 2000s. We covered everything that predates this with relays. So definitely check those videos out if you haven't. A lot of times we have to go back down this timeline to what predates the 1990s. However, you can still stock simple blower control boards that aren't that expensive, that give you that efficiency and that savings you're trying to get out of that unit. That coil is either warm if it's in heat mode or cool if it's in cool mode, and we can get more dehumidification, more efficiency out of that, and higher comfort if we start delaying the blower motors on a off delay. And that's the thinking behind these blower control boards. There's several different blower control boards that we're going to go over and integrate onto a PSC motor before we get into the ECM motors. By the time we get down to present day, we're losing components. After we're done talking about these boards with run capacitors on PSC motors, there's nothing but ECM modules to go over with a control board or without a control board. By the time we get here, everything's integrated into the back side of that, which is very proprietary. A lot of times we don't have the availability to just go ahead and put another ECM in there. And sometimes we have to go back down this timeline, and you may not have a relay. I always recommend carrying at least one blower control board with you if you're still trying to leave it in this condition and still give them the efficiency that they have here. You may not be able to get the same ampacity savings, that amp draw that's lower on ECMs opposed to PSC motors. However, you can get that delay and run time on an off cycle and get more efficiency out of that coil. Getting right into it, we're going to go ahead and wire it up. Took the liberty to notate which one is common and normally open, normally closed. If you look at the one that I have here, it looks a little bit different depending on the manufacturer. It's not a big deal. Both of these are actually made by ICM. This one has my common terminal over here that I'm holding in my hand. On this image, the common terminal is over to the left, but pretty much the normally closed portion is always going to be on the top side, and the normally open will always be in the middle closest to the common. Typically, you're going to wire your motors to your normally open. However, Earlier in the video, we wired the normally closed portion to a light bulb just to show you that there's always power present between common and normally closed when there is no call for G. All right, we have L1 and L2 transformer. We have a low voltage terminal block, a thermostat. We have our light bulb up here giving us a neutral. We have a run capacitor, the ICM 255 blower control board, and we have a diagram of our motor windings, run, start, and common. We're going to go ahead and get right into it. First thing we're going to talk about is safety. That safety that you need to keep in mind is imperative. Okay, we have L1 and L2, so out there in the field where you're working, you're typically working above your head. If you're working in an air handler, they're never really eye level. So sometimes you're standing on something, trying to get in there. Sometimes you can just reach it just fine, but you have to keep in consideration when you're trying to rewire something, you can't just go off of colors, you can't just go off of wire gauges, because sometimes you have a lower wire gauge that is typically wired to something that, you know, is at something that's low voltage or high voltage, and if you're just looking for that itself, that American wire gauge number may not be printed on there, so you don't want to just go off of the insulation and how thick it feels or anything like that. What you want to do is, instead, is you want to verify where's one end of that wire going to. Is it going to L1 or L2? Because the last thing you want to do is take something that's colored red and just start wiring things together, because then if you cross those paths, you're going to hurt yourself and you're going to cause harm to the equipment. So keeping that in consideration, it's better practice to actually take one leg of power, wire it up to all your devices, and then when you can inspect that and verify that path is correct, then you can work on that next step, that next leg of power. So we're going to go ahead and do that here. We're going to go ahead and take L2 and get my marker size just right here. Okay, we're going to take L2 and we're going to land everything that L2 needs to be on, and then when we're done with L2, we'll step back and inspect it, verify that everything looks good. Once it looks good, then we'll go to L1. Now, I don't have to do it in that order just because L2 is the closest thing to my transformer. I'm just starting off with L2. Where else do I want L2? Okay, well, I want to wire L2 to my common terminal on my blower relay of my blower control board. And where else does L2 need to go? Well, L2 needs to make it to the motor, but if I want to break L2, I'm going to come off my normally open portion of my relay. So I'm going to just draw a output symbol there, and I'm going to take that over to my common and look back at it and say, okay, what needs to be changed? Think I'm good. Let's go ahead and label them. That's L2. This is L2. This is going to be L2. And this is going to be L2. Where else does L2 need to be present? Right now, nowhere else. So now we're going to go and work on the other leg of power. I'm going to come over with L1. And I'm going to come over and land that. We're going to come back and we're going to go ahead and label it. Where else does L1 have to be? Okay, L1 needs to be on my run winding. Okay, it needs another leg of power. We're going to go ahead and label that. And then L1 also has to be over at my capacitor. And the reason why we have to do it that way is because if I used L1 for my run winding, then I also have to use L1 for my start winding. We're going to go ahead and label this. We're going to come out of here as an output. And we're going to come over to our start winding. And we're going to go ahead and label it. Where else does L1 need to be present? We landed all our high voltage terminals. We didn't wire the light bulb yet, that's okay. But that's pretty much where everywhere L1 and L2 need to be present. Now, because I don't have any voltage here yet, I'm still open. So if I want to look at where am I reading power, I'm not reading L2 here, and I'm not reading L2 here. Because of the path of electricity, okay, that theory suggests that I'm actually reading L1 here. So we're going to go ahead and erase that value, and we're going to go ahead and erase this other value here. And what we're going to do is we're going to write down the value that I would actually have there if I measured it with a meter. And so this is going to be L1, and right now this is also going to be L1. Now the reason why, if I took my meter out and I measured across this relay that's on the board between common and normally open, I'm going to read L2 plus L1, which is 240 volts, the same as I would read it here or here. There is no L1 plus L2 on the motor yet because L2 hasn't made it across. So path of electricity puts L1 back here. So you got to be careful, there's still power there. We're going to leave it like that until we wire it the low voltage side. Let's go ahead and get some more colors in here that we need. We're going to go ahead and take 24 volts. We're going to go ahead and energize our terminal block. Come out of our terminal block, we're going to energize the thermostat through the base plate. The face plate will energize the moment we have a path of electricity right back to the transformer. Okay. And now we can energize, and then with proper programming, we're going to get a Y call, a Y and O call, and a G call. I don't have a W, I don't have a heat strip up here. We're not trying to make that today's focus. We're just talking about the blower control board and what we need to get this motor to come on. The other items are on here because they are in our immediate scope, and we want to know where we're getting power from. What's telling what to come on, so we put that in there so it's in your frame of mind. We have Y and O. So we have our O call, which comes from the thermostat. We have a Y call that comes from the thermostat for cool, or if it's a heat pump, Y call by itself is for heat. Y and O if it's a heat pump, 24 volts on both of these if you want the heat pump to come on in cool mode. Neither one of these two are going to be wired up to our blower control board, but our thermostat should always give a 24 volt call on G with these other two outputs. So when I take that G call, I'm going to apply it to the board, but this board is a working load. It needs 24 volts at all times. So it's not going to work without having the call for red at all times. So how we do that is we're going to come down here from the terminal block, and we're going to come in and we're going to land 24 volts input on the blower control board. We're going to come out of the blower control board, back over to the transformer, and now the board is on standby. It is ready to receive 24 volts, and the moment it loses that G call, it's going to hang out and provide L2 right here for a 50-second countdown on an off cycle. Let's go ahead and put the G call up there. The G call off the terminal block over to the blower control board. That now puts L2 here. I'm going to go ahead and erase this value. I'm going to go ahead and erase this L1 value here. We're going to go ahead and take these arrows off because we're about to change the path of electricity. And what we're going to do is we're now going to say that this is L2. And because that's L2, then over here we have L2, and our motor will come on. Now the moment we take our G call away, then what happens is L2 is still going to be present there for a 50-second countdown. Once that 50 seconds is up, Power will now be present on the normally closed portion, and this will go back to L1. So we're going to go ahead and draw that back, and we're going to say L2 will no longer be present here. After 50 seconds, it'll no longer be present there. What will be present is L1 and now L1, but L2 is still going to be present over here on this top portion. I'm going to draw another arrow, and we're going to label that L2. So if I wanted to wire up my light bulb, I would actually come off of this, and I would come over to my light bulb, and I would say, when I'm not running, if I wired that over to here, then my light will be on. And say I wanted to say that when that light is on, that's an indicator that the machine is off. And when the light is off, that's an indicator that the machine is on. And how do I know the machine is on? I feel air coming out of the vent. If I don't feel air coming out of the vent, I got a light bulb. It's whatever you want to do. That's more building automated stuff, you know, where we need these normally closed terminals to do something for us. I just want to show you that you could do something like that. I would not wire two speeds here, like a low speed and a high speed, because there is a brief second where power is on both of these terminals for about a second or two. You don't want to energize two motors at the same time. That could hurt your motor, or two windings at the same time that can hurt your motor. I'm going to show you how you would traditionally wire this up so I don't leave off on this note. I'm going to go ahead and clean it up and redraw this up. It's easy to erase it, especially when we know what we're doing. And we're going to do this again step by step. It's very easy. Okay. We're going to go ahead and take L2. We're going to go ahead and land power on the transformer. We're going to go ahead and land power on common. You know, this is also good too if you had to replace everything in your control panel with a new motor, new transformer, rewire your terminal block, new capacitor, you know, new thermostat, new blower control board. If you had to rewire everything, this is what you would do. And then out of this, you're going to come out of your normally open, and you're going to wire your common terminal. You're going to step back, you're going to inspect it, see if anything else needs to happen. You're going to go ahead and just check them off. Everything looks good. All right, I'm going to now go ahead and wire up my L1. I'm going to go ahead and start wiring up my motor, my run winding here. I'm going to go ahead and wire up my run capacitor. And then my third leg of power, even though it's single phase, so I can have polarity, will be on that start winding. And now it looks like everything is pretty much checked off. Everything's done there. Only thing that's left is the transformer and the rest of the low voltage. We're going to go ahead and run 24 volts over to our terminal block, out of that, over to our thermostat, out of the thermostat, back to our transformer. So we have a path on the low voltage side. Now we'll have a display. We're also going to go ahead and wire up R and C on the blower control board. There we go. And the only thing we're missing is the G. We're going to go ahead and give it a G call. That's going to come from the thermostat. Add a G on the terminal block. We're going to come over to our blower control board as an input. And now L2 will be for sure present here and energize the motor. And it's very simple to wire this ICM 255 blower control board. Very easy to wire this up. Now, if you wanted to break any one of these, you would just break your red here through the float switch. Actually, if you come out of your transformer, you should go into your fuse, out of your fuse, into your float switch, out of your float switch to here. This way, if your float switch trips, you lose power on the thermostat. And even if this was on a off delay, it immediately shuts off, so everything's just down. Nothing can come back on. That's pretty much everything that we need to go over on this. The ICM 255 blower control board is not an expensive truck stock item. If I wanted to carry one of these as a permanent fix, because I had to convert an ECM motor back to a PSC, I would probably put one of these in there opposed to a relay, just because I'm getting more efficiency. I think the customer would like that too. Plus relays, they make a pretty loud harmonic sound inside. The air handler is filled with metal. It has a clicking noise, and these are a very quiet choice. So you don't hear that click like a 9340, a 9380, or a contactor, or anything else of that choice would do. Sequencers are a good option too. We covered a video on sequencers. There's a delay time on and off. But if you wanted to just go and integrate a board to it, this is good to go. If anybody wanted to keep that in there and then grandfather back in the module, then you can still wire this to your module, which we'll show you too. That it's one additional relay, but it's okay. That's pretty much it. Hopefully this video gives you confidence. Stuff is very easy. The complexity is within our own minds. We have several different ways that we teach this, practical and unpractical applications with a smart board, how to wire it up. We try not to get into schematics too much because we want you to know what you're doing. Those schematics aren't always available to you, and we need to understand this stuff, memorize this stuff, get muscle memory down. You're not going to get that if you're just exchanging part for part. If things are failing, get down and find out why. Make sure things are wired properly. Practice safe wiring, safe tips, the things that we talk about here. Again, we appreciate all of our subscribers. We appreciate you for liking this video. Please share this with others. There's a share button on your screen. Leave a comment in the box. We'll read them. Thank you and stay tuned.